Hello viewers, myself is Dr. Vadiraj B. Tangur, Assistant Professor, Sri Jagadguru Tontavariya Government First Grade College, Mundargi. So in this video, I am dealing with the thermal physics and waves. In that, I am talking about the few concepts about entropy. This is for BSc program in physics subject for the second semester and for Karnataka University Dharwad syllabus. So my topic is very much narrated to entropy in reversible and irreversible process and second law of thermodynamics, and the name of the paper is thermal physics and fluid mechanics. Learning objectives of this session is to know the concept of entropy, entropy in reversible process, entropy in irreversible process, second law of thermodynamics, and entropy. Session outcomes are knowledge of entropy, understanding of entropy in reversible process, concept of entropy in irreversible process, idea about second law of thermodynamics. Prerequisites for this discussion is concept about first law of thermodynamics, idea about second law of thermodynamics, basics of heat and temperature, concept of reversible process, and concept of irreversible process. And syllabus prescribed by university is concept of entropy, change in entropy in reversible and irreversible process, entropy temperature diagram, second law of thermodynamics. Contents of my today's discussion is concept of entropy, change of entropy in a reversible process, change of entropy in an irreversible process, second law of thermodynamics narrating to entropy. Change in entropy in a reversible process. Let us consider a complete reversible process, a Carnot cycle ABCD as shown in figure. So if you plot the PV indicator diagram, pressure is along y-axis, volume is along x-axis, then A, B, C, D represents Carnot cycle. AB is an isothermal, BC is an adiabatic, CD is an isothermal, and DA is an adiabatic. AB is an isothermal. The amount of heat absorbed is Q1 and at constant temperature T1. Similarly, the cycle CD, amount of heat rejected is Q2 at temperature is T2. This is a complete reversible process. In this reversible process, isothermal expansion from A to B, the working substance absorbs an amount of heat Q1 at temperature T1 of the source. Hence, the gain in the entropy of working substance from A to B is given by Q1 upon T1. Source loses this heat Q1 at temperature T1, so its entropy decreases by Q1 by T1 amount. Next is during the adiabatic expansion B to C, there is no change in entropy. In the next instance, during the isothermal compression from C to D, the working substance gives out a quantity of heat Q2 at a temperature T2 to sink. So the loss of entropy from C to D of an isothermal is given by Q2 upon T2. The sink gains this heat Q2 at temperature T2, so its entropy increases by Q2 by T2. Again, during the adiabatic compression from D to A, there is no change in entropy. Change in entropy in a reversible process, thus the net in the entropy of a working substance in a whole cycle A, B, C, D, A is Q1 by T1 minus Q2 by T2, that is A to B minus C to D entropies. But for a complete reversible process, the ratio Q1 by T1 must be equal to the ratio Q2 by T2. Therefore, net change in entropy becomes Q1 by T1 minus Q2 by T2 is equal to 0 because Q1 by T1 is equal to Q2 by T2. Hence, in this cycle of reversible process, the entropy of the system remains unchanged, or the change in entropy of the system is 0. That is, closed integral of entropy ds is equal to Q1 upon T1 minus Q2 upon T2 must be equal to summation of Q by T must be equal to 0. This equation is referred to as Clausius theorem. Change of entropy in an irreversible process. Irreversible process is the process in which reverse is not same as forward reaction. Such kind of a process is called irreversible process. Let a system consists of two bodies at temperature T1 and T2 respectively, where T1 greater than T2, heat flows from a higher to a lower temperature both by conduction and radiation process. Let Q be the amount of heat transmitted. Decrease in entropy of hotter wall is Q by T1 and increase in entropy of colder body is Q by T2. Therefore, the net increase in entropy of the system is given by Q by T2 minus Q by T1, which is a positive quantity since T1 greater than T2. Thus, there is an increase in entropy of the system during an irreversible process. This is known as principle of increase in entropy. So, we will recapitulate what we have discussed so far. Change of entropy in a reversible process. The entropy of the system remains unchanged, or change in entropy of the system is 0, that is called Clausius theorem, and in equation form it is written as closed integral of ds is equal to Q1 by T1 minus Q2 by T2 must be equal to summation of Q by T is equal to 0. Change of entropy in an irreversible process. An increase in entropy of the system during an irreversible process and is known as principle of increase of entropy. Now, second law of thermodynamics. It can be stated in a number of ways. We have given below only a Kelvin-Planck and Clausius statement of the second law of thermodynamics. So we will state now Kelvin-Planck statement of second law of thermodynamics as: it is impossible to get a continuous supply of work from a body by cooling it to a temperature lower than the coldest of its surroundings. Clausius statement: it is impossible for a self-acting machine, unaided by any external agency, to convey heat from a body at a lower temperature to a body at a higher temperature. Heat can flow a higher temperature to a colder temperature. A heat engine may absorb a certain amount of heat at a higher temperature, convert a part of it into a mechanical work, and gives out the rest of it at a lower temperature. Thus, we see a heat engine works essentially by destroying the temperature difference between the source and the sink. This leads Lord Kelvin to state the second law of thermodynamics in the following manner. It is impossible to derive continuous supply of work by cooling a body to a temperature lower than that of its coldest of its surroundings. This is all second law of thermodynamics connecting with the entropy. If you have any questions, you may to send the questions to my WhatsApp number. Thank you one and all for your patiently hearing my talk. Thank you one and all.